of a segment indicated on a circle with a fairly complex diagram to it. So let's start with number 4 and let's take this apart piece by piece. First, let's look for a radius, and we've got one here, and the radius is 16.2. Here we have another segment that seems like part of a radius. If we continue out, it could be. And we have a chord. And we are asked to find this segment of the chord, which is, we don't know, we're trying to figure it out. So here's the key to this one. We understand that we have a chord and we have a radius that is perpendicular to that chord. That is, if we extended this outward, we would have a radius. And we know that if a radius is perpendicular to a chord, it bisects that chord. So that means that this segment is congruent to this segment, and if that segment is congruent to that segment, then we can simply state x must be 14. And that's all the more complicated number 4 is. It's just using that fact that if a chord and a radius are perpendicular, the chord is bisected. Number 5 is only slightly more complicated. Number 5, our unknown quantity is the radius. We want to know how long the radius is to this. So we look, we know all the radii in a circle are congruent, so do we have any other radii? Well, here's one right here. And I know its length in 2 parts. I know that 4.8 and that 7 right there. And so if I add those together, it gives me the total length of the radius, which is what I was trying to find. So I can say that x would be 4.8 plus 7, or 11.8. Alright, next we're still going to be looking for these line segments, but it gets a little more complicated. So let's take a look at number 6 here. We're looking for this bisected length of chord. So knowing nothing else, I can say that that's congruent to that. So all I need is some way to figure out what that side is, because it'll be the same as this one. So there's a couple ways I can go about this actually. I know this 13.1 applies to this line segment here. 20.4 is the radius, so I know that that's also 20.4, and that's 20.4, and that's 20.4, not that it matters. And I want to know this. Well, I know this is a right triangle, and anytime I have a right triangle and I'm missing a side, I can use either trigonometry or the Pythagorean theorem, depending on the circumstances. Here I know 2 of the sides and I'm missing 1, so I can use the Pythagorean theorem to say that a squared plus b squared must equal c squared. And in just substituting in what I know, a would be one of the legs, which I'll call 13.1. B is x, we don't know what that is. And c is the hypotenuse, which is 20.4. And so now, in order to solve this, I'm going to say x squared is equal to, well, I subtract this 13.1 squared, and so I'll have 20.4 squared minus 13.1 squared. Huzzah for calculators. Let's pull this out, and we can say that 20.4 squared minus 13.1 squared is going to be 244.55. But that's the value of x squared. I want the value of x, so I'm going to take the square root of both sides, and I'll find that x is equal to about 15.64. So here I'm going to have to use the Pythagorean theorem to find that. Alright, and number 7, we're going to have to use the Pythagorean theorem again, but now there are even other things I need to figure out. First, let's talk about this 42.2. Labeled there, that means that's the length of the diameter. Lucky for us, we know that the diameter is twice the radius, so every one of these lines that's a radius, that line and that line and that line, is going to be half of 42.2, which is 21.1. So now I know that that's 21.1, and I know that that is 17.5. and I'm looking for that. Well, I can't find this directly, but I sure can find this using the Pythagorean theorem. Not b squared, excuse me, got the Pythagorean theorem on the brain. So let's call this b and let's find that. We can say, just as in the last problem, a squared plus b squared equals c squared. A squared is going to be 17.5. I have no idea what b is, that's what I'm trying to find. And c will be 21.1. So I subtract 17.5 from both sides, and what I'm going to find is that I get 21.1 squared minus 17.5 squared is 138.96, but that's b squared. I want b, so I'm going to take the square root of that, and that gives me 11.79 for b. So if b is 11.79, I can now say that b and x together make up the radius. So b plus x has to equal 21.1. I don't know what x is, but I just found that b was 11.79. And so now if I subtract 11.79 from both sides, I will be able to find that x is 9.31.